This is ServoShock. It's a small circuit that allows you to control up to 10 RC servos and motors with a Sony DualShock 3 game controller, which can be connected via USB or Bluetooth. 4 servos are controlled by the analog sticks, 2 by triggers, 3 by the X, Y, and Z accelerometers, and 1 by the gyroscope. The digital outputs are controlled by button presses and trigger pulls. One of the important features of the ServoShock controller is a number of adjustments that can be made to the outputs. For example, you can choose whether you want the servo to operate in absolute input mode, where the analog sticks directly control the position of the servo, or in relative mode, where the analog stick controls the velocity of the servo. You can also change the trim, range of motion, direction of travel, and sensitivity. You can implement a center deadband and recalibrate the null position of the analog sticks and accelerometers to correct for any signal drift. The RC servo outputs can also be changed to a regular PWM signal for controlling DC motors. Each of the digital outputs can be configured as momentary, toggle, and autofire. They can also be inverted if you prefer to have an active low output. You don't need any programming experience to configure the ServoShock. In fact, you don't even need a computer. What you do is you hold the PS and select button down for 3 seconds, and you'll enter into a special configuration mode. You can then cycle through each of the 27 outputs and make adjustments. For example, let's say you want to adjust the center position of the servo controlled by the right joystick's X-axis, which is on channel 2. You tap the right shoulder bumper twice to cycle to channel 2 configurations, and press the left or right direction pad to adjust the position. When you're done, hold the start button for 3 seconds to save the changes. If you want to pull the raw data from the DualShock controller, you can use the SPI bus interface to read the packets. The LEDs and the rumble motors on the DualShock can also be controlled with either the I/O pins or the SPI bus. There is also a demo board available that can function as an Arduino shield. RC servos can be plugged directly into this demo board, and an Arduino can read the controller packets via the SPI bus. It also has a USB to serial bridge that allows one to upload new firmware and read the controller console output when making adjustments. We hope you'll find the ServoShock controller useful for your next project. Thanks for watching, and be sure to check out the datasheet to see the full capabilities and specifications of the ServoShock controller.